Hi, Garima. Am I audible?
Hello, ma'am. Yes, you're audible.
So, in the last session, actually, we were doing this R. I hope you have completed this exercise. And there are no questions.
Ma'am, I was able to complete only one exercise. The other one is pending, but
Oh,
I'll do that also.
okay, no worries. So, complete that too. If in case there is any questions, you can ask us. We'll continue with the new topic for today. Uh, we'll continue in the same that we started before doing that exercise, which was our for spatial analysis. That day we were just we have seen what is SF and few syntaxes and the installation and the setup of R. Today we will do a full hands-on using SF library and ggplot. That day also we tried to do some kind of a hands-on, but there was some issues we were facing with the plotting and everything. So today we'll start with the hands-on only. We'll not spend much of a time in the theoretical part, which was mostly like knowing what all functions are available, read, write, STSSF, ST-buffer, and union. Anyways, we are gonna use all these functions in the coming exercise and samples so that you also know how to use all these functions. We'll first start with the vector and then we'll move forward to the raster data as well, how to do analysis. The first exercise that we're gonna do is know how to read any of the vector data, how to inspect the geometry type, how to transform it CRS, check CRS, and then if needed, how to change it into different CRS, then calculate the buffer and then simply plot that buffer data. We have completed this exercise as well, but I'm just redoing it again one time. So simply for handling any vector data, we have a library called SF, which will use simple feature library and then ggplot for doing the basic plotting that you want to do. ggplot also helps you with a lot of color and a lot of manipulation in terms of how you want to visualize your data. Whereas we have also studied about the T-map and the basic plot in the previous session, which was only for the basic plot was for the static plotting, and then there was T-map all library as well, which you can use for the plotting. So there are a lot of libraries for multiple plots and everything. You can use alternatively whatever you feel comfortable with and whatever you want to. So first of all, we'll load the library. We will select this and run this. So we have already loaded this library. But before loading, one more thing that we have to first always check our directory, that in which project directory you're kind of working on, because from there only you will be able to fetch your data. Otherwise, you have to put your complete uh, path of the data. So since this is my project folder where all my data is stored and my scripts are also stored, so I will be creating this project folder as my working directory. So there are multiple options to you set this working directory. Either we can use the command like set wd and then pass the path. This will also help you set the working directory. And how we can check that what is the current working directory is get wd. If you enter this, so right now my working directory is C drive, but I want this to be changed to this project folder. So I have opened this project folder here. So what I'll do, I'll go from here, from here in this mode, I'll go and set as working directory. So automatically this command has run here, set working directory and pass the path. Or if you want manually as well, you can write from here in the code, set wd and pass the path and then enter. It will also set your working directory. Now working directory is set to the project. We'll also check that if it is changed or not, get WD. So current working directory is D/0505 slash project is our current working directory. Good to go. Now we'll simply go to our data and whatever data we want to work with, we'll use that data. So there was some issue with census. So we are going forward with the parsers.gpkg for now, which is this data. For reading any data, vector data, st underscore read, gpkg, geojson, or any shapefile, all the data can be read through this command only, st underscore read, no separate commands. Then once this arrow and dash is used to assign, means this is like a equal to sign, assign the variable called blocks. Then if you want to check the geometry, so st underscore geometry underscore type is used to check the geometrical type. So and then st underscore crs is used to check this. Yes, I'll select this much part and then I will run this much part. So the variable is created for the blocks and we got the output for st geometry type and the CRS. The CRS output is this WGS 84 4326 is the CRS, and for the geometry type is this. So you can see that it is the polygon. There are four geometries, so it will give you individual feature geometry type as well in this. Next, if you want to transform, means you want to change the coordinate system. So we'll simply use st underscore transform and then pass whatever CRS you want to pass. Select this and run this. Now it is changed. Now if you check the CRS for the block project, if I pass it here, select this, run this, so it is now 32633. It is confirmed. Buffer for doing any kind of operational spatial operation, the concept will be same. It either in R or in Python, concept is not going to change. So the concept about that if you are doing any kind of spatial operation, your coordinate system needs to be in UTM. Why? Because you are doing the calculation and the straight line distance calculation and all those things. So for that reason, it should be in the metric measurable format. That's why we need it in UTM. Hence, we converted it into 32633 before doing any buffer operation in this case. For doing the buffer, simple function that you can use is st underscore buffer passed the SF object that we have created, block project. How much buffer you want to give, we gave in the distance, and then we can select and run this. So buffer is also created here. Now we will plot this buffer and our data, both of the things. We'll plot it using ggplot2. So we have seen how to plot ggplot2. We use geom sf to plot multiple layers. If we don't have multiple layers, only a single layer, then in that case, we can directly pass the data to the ggplot. Let's suppose here we have multiple layers to plot. Like the original data, which was block projects, and the buffer data, which was after doing the buffer calculation. So since we had two data layers, so that's why I used geomsf two times. And then I also want to plot the boundary as separately with the separate color. So I gave the boundaries separately. So there is a direct function in R which helps you directly visualize only the boundary. So in any of the polygon data, if you use st underscore boundary command and you pass your boundary, pass your data SF object, it will directly just fetch the boundary and do not give the color to your inside. Do not give the fill color. It will only fetch the boundary and just displays it. So that is the better way to directly plot the boundary in terms of visualization without giving the fill color. So geom, you pass the data, buffer, block projects. Then here we pass color. Color is the boundary and the fill color as well. Both we want as orange. Size is equals to 1 means the thickness of your boundary. Same for this. Alpha means the transparency as well. We passed into this now. The block. And same for the boundary. Coord SF, it will make sure that the coordinate, it is correctly assigning the coordinate system to this plotting. And then theme minimal, there are multiple options of theme, but we are choosing minimal theme for now. So we'll select this part and I'll run this part. So you can see that we have plotted all the four polygons and with this orange as a buffer on the side. Here, 5 of this part. See, now white boundary is removed from here, from this position. White is not present because I removed that boundary part. So only orange buffer is there. If I increase the buffer size, let's see how it affects our output. We are not able to visualize it properly because it is scaled too much. But this is how basically we can do the buffer in any of the layer that we might have. Okay. In the same way, in the ggplot, we can also add legends as well. So if you want to add a legend, simply here geom sf data buffer aesthetic fill is equals to buffer. So if you want to have any legend or something, then we have to add the aesthetic part as well. So aesthetic, whatever you will add means however you will define in the aesthetic that your fill color should be, means you are defining the legend, means in this data, whatever the fill color is, give that as a legend in that. Means here in this buffers, I assign that my fill color for the buffer is orange. So I gave in aesthetic fill is equals to buffer. So the orange color is also filled in the legend as the buffer in the buffer category. Similarly, here in this as well, plus sign, I guess we already discussed why we are using plus pluses. Everything that you want to add it on top of this in the ggplot, you will keep on using plus 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 and keep on adding it. So geom.sf here, if you see in this block projects, so in this aesthetic fill is equals to block here. So here fill is equals to block in this category. And then here you can see here we gave the final color that what you want to pass in the buffer and the color that you want to pass in the blocks. So in blocks, I want steel blue and in buffer, I want orange in this category. This color is actually the boundary color. Color is giving the boundary color, fill will give the fill color. Here also, fill was giving the fill color and color was giving the boundary color. The same goes here as well. Then same chord SF, and then this line is extra for the legend. Labs will help you add the legend, and fill is equals to layer means this layer title will go into fill in the labs. Labs is the key for legend in this. Then there are multiple other ways here. If you see here, we remove color and included size. Everything else is same. So different is just no space between them because there is no white outline in this. So that's how basically you can play around with the ggplot for basic visualization and all those things. In the same, let's suppose you already have some data and you want to do some area calculation and want to add a new column into your existing data frame. And then for doing after calculating that area in the kilometer on the meter square. So we'll take this 2001 district shapefile only. So library SF, library ggplot2. Then we loaded our data senses this shapefile we loaded here correctly, and then we are checking the transformation. So we'll first run this much part. Okay. And then after doing the projection, now in this line, if we, what was the command? Anybody remember? What was the command for viewing the table? I want to view what is there in this particular table right now. How can I view it? In the previous session, I have shown you how to open the data as a table. without geometry and with geometry.
Ma'am, do we use DPLYR?
No. DPLYR was for filtering. If we were last time we were filtering the layer data on the basis of some logic, some attribute information. That was the use case of DPLYR in case you want to change anything in the data. Right now, my problem is I just want to see what is present in this. Then only I will be able to update the columns and add few more things into that column, right? Anybody else? Okay, fine. Let it be. So there was a command called view. So view, and then I want to view NC. So I'll get the table like this. So now I'm seeing the whole table here. So I'm getting an idea. Okay, I have state name, I have codes, I have district codes, I have district name. In front of it, I have to add one new column called area, and I want to calculate the area for every single state. Oh, sorry, every single district here. So for that reason, simply for adding any new column, simply you have to write your SF object, this sign and the name of the column that you want to add. Then whenever we create any new column into our GIS data frame, we know that we have to define the data type of that new column. So obviously how I want to add that column as numeric. I want to add that column as a numeric data type. Then in that column, what value should go in that column? I want to calculate the area and put it in that. So st underscore area will help you calculate the area for every single geometry that is present in that. So if I run this and then I will just do nc underscore proj. So I got a area here. But right now this area is in meter square. Why this is in meter square?
Ma'am, what was the question?
The question is, in this line, I have calculated the area and stored it in this column. But the area is in meter square. So why this area is in meter and not in kilometers?
Because in UTM, the units are meters.
Correct. So because in UTM, the units are in meters. So now what we'll do, we will convert them into the kilometer square. So then we will use two important methods, which are set units and as numeric. So in set units, what we are trying to do here is we are just set unit is just to define or change the unit of any variable. So in the set unit, we first change the unit of this particular variable in the very first case. We haven't calculated at this point. We just converted the unit of the output here. So set unit st area nc projects. We created a new column area kilometer square and then set the unit to kilometer square. Then in this case, okay, let's first run this much only. Just a minute. So this package is actually, I guess, required for SPET units. We'll check after this. You have to load as well. So library unit. Okay. Now this is loaded. Now we'll check for the settings. So now this is fine. So here, if you see that when we use set unit, so in the same it calculated the kilometer square, it had also added whatever we added at the end, like kilometer square. So what I have to do, I have to separate the numeric part and separate this kilometer square from this. So for that reason only, we are using this as the numeric. That's it, no other reason. So now when we will do this, so you can see that now I don't have that kilometer square at the end of this column. So this is how basically, this shows us two things. One, how you can add any new column, and how you can calculate the area in R. Any column you can add in a similar way just by writing using the symbol and just by writing the name of that column, and then accordingly doing the process that you want to do for calculating what value should go into that particular column in this. There is another thing which is name. What name will give us? So name, if you run here, the name will give you all the names of your column. So in Python, it used to be either index or the head or something like that. Here, if you if you write names, so it will simply give you name of all the columns that are present in your SF object in this. Here as well, if you use head, it will give you basically first like this 1, 2, 3, 4, 5. So these many outputs it will give you like the top 6 ones from here. And there is no concept of zeros in the like that. So first output it will give you like this in the head. Then plotting is same, but before plotting, we can calculate centroid as well. So for centroid, there is a direct method which is st underscore centroid. In this, my way of calculating centroid for plotting, I want to plot the complete polygons, and then on top of that polygon, I want to plot a centroid point for every single district. So it calculates centroid as well. Now we got the centroid value in this, and now we will plot it using ggplot. So in ggplot, either if directly on a single layer you want to plot, you can directly pass the data in the ggplot. Geom SF aesthetic fill is equals to area for the legend and the color is equals to white. Then scale fill vivid, how do you want to fill the scale in terms of in your legend and everything. And then chord SF for managing your coordinates. And theme also that way. Okay. But here we haven't managed how you want to plot the area numbers because we are taking which column? Okay, we are taking that area column. Let's take this area kilometer square column instead of normal area. Area underscore kilometer and square. So now, because in that case, meter square, it was not able to give the exact number properly. But in this, we gave the kilometer one for the area legend, how it should categorize and how it should scale the colors and everything. So it gave us properly like this. And similarly, how the scaled color mapping is coming. This is coming from the scale fill vividness. So there are a lot of options for this as well. For knowing what all different color options are available, we have to check the documentation. So here, ggplot, we pass the data in this, initialize the plot first. What do you want to plot? Means your SF object will give, this will set your default data set for any kind of plotting in this. So you're starting with this, then after adding this, now you are trying to add your data as a layer in this line particularly. So geom.sf will help you to plot your special data frame from your SF package. AES fill is equals to area kilometer means color your polygon based upon these area value means based upon this fill value, and accordingly this will can directly give you legend, go into legend as well, whatever you fill into this. That same color will go in this as well. Color white means the boundary color, how you want to put the boundary, then the size, what thickness you want for your boundary. So you are just drawing that. Then in this next line, what is happening? You are basically controlling how you want to style your map and everything. So in terms of styling, I want to give the color as scale fill vividus C, and option C means specific vividus planet palette only. So you are specifying that which palette you should use from this scale, because in this scale there are a lot of palettes available. So I want to use only vividus palette. That's why I'm defining that. Trans is equals to SQRT simply means when you are doing this kind of scaling, so there are multiple methods available, like in QGIS, there are equal interval, quantiles and everything. So here also there is a method called SQRT. This means don't just dominate the larger value, just the square root transformation. So it helps you with skewness of your data and everything. So similarly, there are different methods. So SQRT is the most preferred method. Similarly, like we mostly use Quantile in QGIS for doing this color mapping. Same thing. Name is equals to area. We are defining the title of the legend in this category this way. So you may get confused that here you used the title using this slab fill is equals to layer for defining the title. So this is also a way for defining a title, and this way as well you can define a title. But when you are using scale filled vivid at that time only you can define your title here. Then in the in theme minimal base size 12 is just defining what should be the size means what kind of a theme we are just setting the font size of the overall theme of your map. Maybe you are adding a title, maybe you are adding more text and everything. So overall base size you are defining your font size basically, and remove all kind of background clutter and everything using theme minimal. Then in this theme, where do you want to position your legend? So in this, you must have seen that we never defined uh, what position we want for the plot. And automatically it was the default place. But you can set the legend position as well using this theme legend dot position right if you want it on the right. If let's suppose you want it on the left, so this is how you can switch the legend position as well. Any question till this point, till this plotting, what we did?
Ma'am, the base size in the theme is for the font.
Yes, it's for the overall font. Since we haven't added any title as such to our map, but we can add the title to manage the font size and everything. Let's suppose I increase, and also it will handle the size of your legend as well. If I increase this, so it is now increased. The overall size of your theme, that whatever is written will get increased. So base size we can set that. Okay. Anything else?
No, ma'am.
Okay. In this, there is nothing extra in this plotting. I will share these scripts as well for your practice along with the PPTs. So try to practice on your own data. Okay. Now we'll do one more example in which we will explore the DPLYR. DPLYR library, as we have seen a basic example of DPLYR in the last session, but we'll see that in detail. We'll also explore the use case of Terra. Terra library is one of the libraries which is mostly used for raster calculation. So we'll see first little bit of theory, and then in this only there is a last hands-on of NDVI and zonal statistics, which anyways we'll do. But first we'll cover a little aspect of what Terra library is and what is the use case. So in use case wise, all the use case that you can think of with respect to a TIFF file, with respect to a raster data, you can do it using the Terra library. In Terra, similarly, it is a modern package that helps you work with raster. And then in some cases, it also allows you to do some work in the vector dataset, but generally we do never prefer using Terra for a vector analysis. We always prefer Terra for all kind of raster analysis only. For vector, we will only be focusing on SF library. SF package. Then similarly, the moment raster comes into the picture, that means row and column and pixel and cell size and resolution, everything comes into the picture. So similarly for accessing and arranging, so n row and column, spatial extent if you want to check, so there is a command called extent. For checking the resolution, so there is a command for resolution, RES. Like that, all these commands are available. For reprojecting, for checking the CRS, it is CRS only in the Terra. For the SF, it was ST_CRS. Here in Terra, it is just CRS. Then for reprojection, it is project here. And then there is two important key classes in the Terra, which is spat raster and spat vector. So spat raster is for raster handling and spat vector for vector handling. N row and n column will be your grid size. EXT extension is for fetching the spatial extent. Okay, what all things will come into when you're exploring a spatial extent? What do you mean when I say spatial extent? What values it will give you?
The lat long values, like in a bounding box we have.
Yes. So not exactly the lat long. It will give you X minima, X maxima, Y minima, and Y maxima, the corners of your database, of your data, anything. Resolution, what resolution will give you?
The pixel size.
Correct. Resolution will give us the pixel size in that. Then let's suppose in raster data, it can be a single layer or it can be a multi-layer. When it is a multi-layer means there are multiple bands present in your data. So one band layer can be there and stack of bands can be there. Or then there can be a continuous data, there can be a categorical data. Continuous data will be like temperature, elevation. Categorical data will be like a land use classes and all those things. When it comes to data type, so in raster data, values of the pixels can be either in an integer or can be either in a float. So generally, when a raw data is present, it is mostly in the integer format only. But before we do any kind of calculation, we always tend to convert our data into float. Why? Why do you think so that before doing any kind of a raster calculation in the pixels, we often convert our data into a float data type?
Because float can have decimal values.
Yes, because float can have decimal values, and in most of the raster calculation, your pixel values can be 0, 0.2, 0.3. All those values are like that, but the original data type is the integer only. So we change it to float so that it is not giving us any kind of an error when we are doing division or multiplication or those kind of calculations in that. So that is the basic use of all these things. Then CRS and alignment, so that we have understood about the concept of the resampling and all those things. Why actually resampling is important. Reprojection, we know why we do the reprojection, because to make it into the correct projection system so that it lies into the exact coordinate, exactly on the current exact position in the earth. Whereas why we do resampling we do so that if there is any errors of transformation, or there is any rotation or translation in your data, or you have two data sets which are of different resolution. Let's suppose you are doing weighted overlay analysis. For doing the weighted overlay analysis between two data sets, one data you have bought from the rainfall, one data is from the DEM, one data is something else, and all are in different resolution. So then at that time, your cell size, your pixel size are not going to match together. So in the cases when your pixel size are not matching together, in those cases, we often do the resampling. So there are multiple methods for resampling like near and bilinear. So all these things are quite possible in this. Similarly in the Python as well, but here as well. You can do all the processes of resampling. Resampling, reprojection are the main pre-processing step in almost 90% of the raster analysis scenarios. Then important is input, output, and memory means how do you read the raster, how do you write the raster. Reading the raster means, let's suppose you have a file, you want to read it. So for vector SF, it was read underscore file. Here it is rast for reading it. Anybody remember how we used to read the file using rasterio in the Python? Sahili, do you remember?
No.
Okay, fine. Read about it. At least watch it from the videos. How to read the raster from rasterio. Okay, so in Terra, you have to use Rast for reading any raster file using the Terra library. Then for writing that raster means how you want, after doing any process, let's suppose you want to save that file to some kind of an output, how you can save it. So we will be using write raster for saving that file. Then obviously we'll use file name as well to give the name of the file while you are writing that raster. So all those things we'll do. Later, there are certain cell-wise, for doing cell-wise mathematics, there are certain operations that you can do. And then for doing the spatial operation. So for spatial operation, anyways, we'll do it in detail. But generally, some special operations are like crop, mask, focal, and mosaic. What do you mean by mosaicing? Mosaicing means, let's suppose you have two separate bands, you want to stack it together. So that will be the meaning of mosaicing. Mosaicing is not like stitching two different area of file together. It is like same area of files, but you are stacking it together. Focal statistics simply means picking few pixels and doing the statistics for those pixels, either a minimum. Let's suppose you are picking certain, uh, let's suppose you have a complete raster for the complete 2, 3 states or 10 districts are lying in that raster, but you want to calculate, you have calculated the NDVI. Now you have a NDVI raster. For every single pixel, you have certain values. So there is a two type of statistics, either a focal statistics or we do zonal statistics. For doing pixel level analysis, you want to group a pixel for a certain area, you want to calculate the statistics, a mean value, a minimum value, a maximum value. For that, we will be using focal statistics or zonal statistics at the end of it. Okay, and then crop is same like clipping only. Like if you want to clip or cut out certain area, then you can use this. Masking is, let's suppose you want to just overlap certain area. So what you will do, you will apply a boundary of that mask. So it will remove those pixels uh, from your calculation, remove all those pixels from your calculation. And then we'll do example now. We have 10 minutes. These things I am not repeating, but they are in your PDF. So you spend some time on reading all these things because we have covered the theoretical concept already in the Python. So conceptually, there is no change as such. It will just show you how you can add it, write it in the R, but there is no different as such. Simply you have to write. Let's suppose there are two objects, you have R1 and two layers, you have R1 and R2. If you want to add it, just add plus, just add minus. So there is no as such very difference in terms of how you write the syntax. So we will not spend a lot of time into this. We'll directly do a hands-on on the NDVI itself, how to calculate the NDVI using the Terra. And there is one question that you should find the difference between zonal statistics and focal statistics. And I think you can come up with the answer. So tomorrow I'll ask that first thing before we start the session, the difference between focal and zonal statistics. Okay. We'll start with the Terra library. Any questions in what we discussed till now? Then I'll start with this.
No, ma'am, no questions.
Okay. Alicia, what about you? Are you there in the class? Okay, so how's your practice going? Are you able to watch the videos and practice whatever we are discussing? You can type in the chat, it's fine. Okay, no worries. Just a simple request because uh, things will move forward very fast. And if you don't practice and if you don't ask questions, so I will be like, I don't have a lot of options that I'll be able to cover only that much, but I can think that that is important for the sessions. And if you don't ask me questions, if you don't try to practice on your own, I'm so sorry, but I will not be able to help a lot more ways that I want to. And in the next track, when we'll, or not just in next track, as we move forward, it's gonna get tougher and tougher. When we'll move towards function, when we move towards automation, when we move towards tool creation, which is anyways the part of this track, not even the track 4. So after that, like for the last batch, when I finished the track 3, we did a 3-day of marathon session where we all created a tool at the end of it. And in that tool, I have also created, and everybody who was there in the class, they have also created along with me. But you will be able to do that once you are thorough with and there was no foundation as such. I'm not asking you to learn the syntaxes and everything. There was no foundation about searching from the Google or anywhere, but you should know how to do things. I hope I'm wrong, but I think you are not practicing or even watching the videos. At least spend an hour daily, or maybe if you don't get the time daily, at least on weekends, spend 3 hours. That is more than enough to cover a week of 5 days of session because I think I teach very, very less in this 1 hour. I can cover very quickly and many lot more things in an hour, but I try to be as slow as possible. I don't want to rant, but just a request, please try to practice. Otherwise, you don't have the portfolio ready. You will not be able to complete your capstone. Either you will be just creating a mediocre project. You will not be able to create extraordinary project. So in some time, like in the next 2 to 3 weeks, anyways, Nagin will also gonna share other people's project, what track 4 students are doing. And they are creating a very nice portfolio, very nice project and everything. So earlier, even for them, actually, I also didn't have a lot of time. because I couldn't focus because of my earlier job. But right now I also have time, but I don't think you are practicing. So please, then only I will be able to guide you on the projects, capstones, or anything once you finish what is the basics. Okay.
Hello, ma'am.
Yes.
Ma'am, I'm trying to do, but I also can't focus because of my job. It's taking too much time.
Okay. When is the last you have resigned or it's still time
June
left?
1st or
June.
2nd week. Within June 15, I will resign.
Okay. Okay. But at least take some time on at least on Sunday.
Hmm, hmm,
Like for example, you sit for this class, right? After
hmm.
coming from the office. I know I am asking you to stretch like a bit, but okay, to be honestly, I'll tell you, when I started taking your sessions, at that time I was doing a full-time job. I was going to office in the morning at 10 a.m. Like 10 a.m. I used to come back at 5, not 5, to be honest, 5:45 something. Every day I used to take your sessions from 7:30. Apart from few days, I don't think I've missed your sessions. And 7:30 to 8:30, and then again I used to have a session from 9 to 10. And I used to prepare the PPTs and data and everything that I have to teach in the class. So that was a stretch, but I guess you can also spend like 1 hour for this class you are spending, finish your dinner or something, at least just watch the video. Even if you think that it is not going in your head and you're not able to do anything more than what I am teaching, so that at least you know what are basic things. Or if daily you cannot sit, maybe on Sundays, take only 2 hours of time and just try to watch videos. Okay? Try to do that, but and anyways, if means it's fine if you after June you should start, but you have to manage your time somehow, because spending the money and taking the course, it will not you'll not be able to get anything out of it. Just that.
Yes, yes, I can understand.
Because then let's suppose whole track is completed. Now everything is piled up. So
Yes.
once you see that, okay, fine, I haven't watched 20 videos, it will be too much to finish everything after. Okay. No worries, try to do that. Else it's fine. No worries, we'll do. We'll continue with this Terra. We'll finish this example first. So if you have to, let's suppose, calculate the NDVI. So for calculating NDVI, though there are a lot of pre-processing step as well, but we'll first do a basic calculation. What all you need to do for calculating NDVI? Read the raster files. In the raster, you have to read band 4 and band 5. Once band 4 and band 5 you have read, then you have to check that what is the resolution, what is the CRS, what is the extent, and all those things you have to check for everything. Then MLYR basically it gives you how many number of layers, means bands are present in that. Since that is I just showed you so that you know how to check number of bands, but that is was not required since this is only a single band, we already know. Then how to resample. For resampler, there are multiple methods. So the bilinear is one of the method which you can use. So you have passed NIR and red and method is equals to bil means resample NIR band with respect to red band. So to match the resolution of both the bands together. So we are resampling it together. Then in this, what you are trying to do here is red comma resampled one. So red comma resampled one is the NIR band here. So once you have this stacking, you have stacked the layer together using C, you have stacked them together, red and resampled is the NIR band only. Now what you are doing here, you are checking the name of the S. We'll first run this one. What names will give us? Names will give us what all columns are there in our vector data. And here, if you check names, just a minute. So we have SRB4 and SRB5 for now. So they are written. Now we are changing this to red and NIR. So this is how we can rename the names. Now if I check names S, it will be red and NIR. So simply you can change the names here. You can stack the layer and change the name. Then finally we are calculating the NDVI part. For calculating the NDVI, since we have stacked both the bands together in S, so there are two layers present in S. So from S fetch the NIR, from S fetch the red, from S fetch the NIR, from S fetch the red. So that's how you are trying to fetch your layers from your stack of bands. Simply the formula was NIR minus red divided by NIR plus red. And you calculated NDVI. Once you calculate NDVI, you can project it to different one if you want to, and then which NPSRS. PRS. Let me check for this. Okay. It is not reprojecting because it is thinking that there is empty CRS, but I have checked the CRS of NDVI. The coordinate system is present in this, but just for the safety, if it is not recognizing, we can assign the SRS here. So I'm trying to assign this here first 326. Check the resolution and CRS for them as well. Doing this, maybe that is why the issue is there. Because as such, resampling was not needed for this. I'll just run it. We'll not run the resampling for now. We'll just directly stack both of them. So instead of resampled, I'll pass NIR only for now. So stacking is done. Then we will rename it to then we'll run only the NDVI section. The output, so it is now writing the output here. We'll check for the projection why it is not reprojecting. Here NDVI test 6 May 8:06 PM. So we got the output here. I'll check this one why it is not. It is giving some warning message of some DB or some random connection error. This is not the problem of the command. Command is this only project. It's giving some other error. Some installation or version issue is there. I'll check that later if there's some different command for this. But this is how only in most of the cases, this project using this command only, you will have to reproject this. Like earlier, it was working in this case. Here only it is not working. I'll check that later, but simply this is how you can do any random calculation in the raster data and write it into the raster finally. Tomorrow we will do the zonal statistics and focal statistics. The only work that I want you to do is to understand the difference between the zonal statistic and focal statistics. Then hands-on we'll do in the session only. Okay. Thank you, everybody. That is all for today.
Thank you, ma'am.